Hello and welcome to Steam It with Steve. Today we're going to carry on with what we've done so far with learning our Introductory to Python and Programming course. So to start with, we're going to look at how a programming language works and why do we use it instead of our normal language like English, German, or Japanese. Okay, so to begin with, what I have is a little statement here. So a computer is only as smart as the person that programs it. Okay, so we look at this image here, give to Steve. The robot or the computer is sitting there and it has a clear instruction to give to Steve, and Steven's standing in front of him. But because there's another N on the end, it doesn't understand and gets confused. Okay, so computers are really simple. Okay, they understand instructions really well, so they can do mathematical equations and processing super fast. But if you give it simple instructions, it can do it. But more complex things that need some bit more depth of understanding, they fail at. Okay, so computers are really good at following instructions, but they're bad at thinking for themselves. And that's our job as a computer scientist, is to make sure that the computer understands very clearly what it has to do so that it has the instructions to follow along. So to begin with, the first question is, what is a program? So I've made a little dodgy program down there. So life motto, if sad is equal to true, sad.stop, so stop being sad, and then be awesome. So that's the new function that you should do if you're feeling sad. So a list of instructions telling a computer to do. That is what a program does. So it goes through and has this particular set of instructions that it must follow, and it goes off and does it. That's all a program does. It must be precise, and its semantics and syntax must be correct. So semantics and syntax just means the logic and then the grammar or spelling of the program. So you want to make sure that's correct what you're telling it to do. And then you also want to make sure that the punctuation is correct. So unlike English, where if you forget a full stop or a comma, the teacher can read through your assignment and still understand what it means and still give you an A. Whereas with a program, if you miss one semicolon or a full stop or a particular word, the whole program will break. And it's really important that we have this level of precision as we're going through so that the program doesn't fall over. A program uses three main control structures. It uses sequence, so the structure that it follows, so just going through line by line in the code. It uses selection, so when a decision happens, it either goes to the right or the left. And then repetition, which basically saves it from doing the same thing over and over. So if you had a video game and it's telling you to punch, right, and you're punching, and instead of you had that, let's say you had to punch inside the game 100 times, right? Instead of doing that 100 times and running punch, you can write a structure called a loop and do it within 2 lines of code, okay? Which is what we'll go through eventually with this. So with computer science, the powers of 2 are super important. So we must learn and memorize these back to front. So 2 to the power of 0 is equal to 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5, 32. 2 to the power of 6, 64. 2 to the power of 7, 128. 2 to the power of 8, 256. And then 2 to the power of 9, 512. These are super important for computer scientists. They are sacred. Okay, they are the building blocks of how the binary number system works, and if you understand them, it makes your life a whole heap easier. Okay, particularly when we're transferring from binary code into normal numbers so we can understand it. Okay, so speaking of translating, what I want you to do is we're gonna put up a couple of words down here, and eventually you're going to understand what the word means. Okay, each one of these words are going to be in different languages, and they all mean exactly the same thing. So as we go down, we're going to have a bit of a think what the language could be. So what language was spoken when it was written, and then eventually, hopefully by the end, we'll know what the thing is. Okay, I'll give you a hint. It is a noun. So that's the first one, right, which I can't do the dignity of actually pronouncing. That's the Urdu version of this word. Then we've got this one. Again, I won't do the attempt, but it's got some interesting characters, but it's obviously a little bit bigger, but it means exactly the same word. So these two things have exactly the same meaning. This is the Punjabi version of the word. Then we have this one, so a whole heap of zeros and ones, which is looking a little bit familiar, and hopefully we're getting the idea. This is the binary version of the same word. Then we have this word, which I'm not sure how to pronounce again, is the Georgian version. Then Hollander, which is the Afrikaans way of saying the same word. Hey hey, which is the Maori or New Zealander way of saying it. This character, which is the Chinese character, and we pronounce it Judu, is another way of saying the same thing. And then hopefully some of you might have picked up, it actually means chicken, which is the English way. So even though we had written the word 1, 2, 3, 4, 5, 6, 7, it wasn't really to the 8th time for us native English speakers that are watching this that we were able to pick up what it meant, right? So if we were Afrikaans, we would have probably picked it up at that point, or Urdu or Punjabi, but a computer would be able to pick it up at this point here, right? So all these languages are awesome, right? They have their own structure that they've built it in, and it's the context that helps you understand what the meaning is. So for English, the word chicken, we hear it, we understand what it means. We see it, we understand what it means. A computer won't hear the binary, but it will read it and understand those zeros and ones, or the ons and offs as it goes through, okay? And that's basically where we're going with this. So what does a computer actually understand? Well, it only understands binary. So it understands 0 or 1, false or true, or off and on, okay? And it uses this code, or binary code, to do actions, store words, and do everything that we're going to be able to do as a computer scientist, okay? So here's a little bit of a joke from Futurama, a bit of a popular TV show.
1 0 1 0.
Bender, what is it?
Oh, what an awful dream! 1s and 0s everywhere. Ugh. And I thought I saw a 2.
It was just a dream, Bender. There's no such thing as 2.
Right, so you should get the joke with that. A binary code, when we write it into a computer, is only a set of 0s and 1s. It never has anything else. It doesn't have a 2, doesn't have an A, doesn't have a B. All the characters that you can normally type, it only understands 0s and 1s. So that computer, the iPhone, the computer in your car, all those things literally uses 0s and 1s, okay? So when we look at binary code, it's a series of falses and trues. So false being the 0s and 1 being the trues, okay? And then what happens is the computer takes that and tries to convert it into some form of context that it will actually understand, okay? And there's a whole heap of different ways of doing that. So to start, we'll look at the ASCII code, okay? So ASCII is the way that we change characters into binary. So for example, if we wanted to convert the letter P into a binary code, it's actually 8 different little characters of 0s and 1s. So all these codes are 8 little bits, or 8 characters. And basically we would put in 0, 1, 0, 1, 0, 0, 0, 0, and P would be coming up. Okay, and that would be the capital version. If we wanted the lowercase p, we would come down here. So 0, 1, 1, 1, 0, 0, 0. So it's further down on the ASCII code table. So ASCII stores all the numbers, the letters, both capital and lowercase, and then also all the punctuation marks, which is pretty cool. Okay, it also stores a few other commands for communication protocols because it was built basically when the internet started, which is kind of cool. So ASCII stands for the American Standard Code for Information Interchange. Okay, it is a binary number that represents a single character or a communication code. It uses 1 byte or 8 bits, so 8 individual little characters, and they merge that together to give it meaning. It has 256 options, or 2 to the power of 8. See how there's 8 bits and in it, there's a connection there, which is for characters and the codes. So for example, if we have 0, 1, 0, 1, 0, 0, 1, 1, we can read through this table, right? And then we get down here, so 0, 1, 0, 1, and then 0, 0, 1, 1. Pretty cool, right? And then that's what the letter S is actually stored right now on that screen. So the way that S is physically stored is with that character sequence. Okay, or sorry, binary number sequence. Okay, so the first thing that I want you to try and do is actually change your name into binary. So please pause the video there, have a go and see if you can convert it. Awesome. Hopefully you paused it. Here's how I converted my name. Okay, so Hendo, Hendo. If we go across and we look for H, there it is down here. So 01001000. Then it went to E. So down here, 01000101. Then the N across here. So 01001110. Then the D, 01000100. Then the O, 01001111. Awesome. Cool. So that's one way that you could do it. The other way, because we're lazy and we're computer scientists, we can actually use programs to do the work for us. So if I go in here and if I type in Hendo, there's the binary code version of it. Okay. If I change this, so this is a wonderful day for us today. See how quickly this computer's converted it into this binary code, right? And the binary code will be significantly bigger, right? So if you start actually writing out, I don't know, the whole of Harry Potter, do you see that the language would get quite big, and the size or the number of zeros and ones that are needed would be getting quite big. Cool. So have a go at that. Play around with that if you want. There's some really cool things. So if you want to change your name, do some other things in binary, there's that option there. So the question that I pose to you is, why don't we use this? Why don't we program in zeros and ones? It's not so bad if we did do that. Right? So why wouldn't we use 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, blah, blah, blah. Right? It's pretty hard, right? So I just want you to pause the video and just have a think before I answer this. Okay, so the reason why we don't program in binary code is the readability, right? It's super hard to read all those little ones and zeros. And imagine if you didn't keep in sequence or using different lines, there's no structure behind what's happening with it. It's really easy to make an error in here. So if you instead added an extra 0 or 1, or if you put a 1 where there should have been a 0, the whole thing breaks. So the code doesn't actually work. It's very ineffective to write. So if you just had the 0 and the 1 key, you can actually do this if you want, okay? But it's really, 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 really hard. And then the other thing is humans don't speak in zeros and ones, right? We don't understand what 0 and 1 means. Then if we had to deal with scale, so imagine if we had to build something massive like Fortnite, the programming of that is doable, but it would take lifetimes to be able to punch out all the zeros and ones in the proper order to make that particular structure, okay, which we don't want to do. Then we can also miss out on the programming libraries. So instead of having to rewrite code, we can borrow from particular languages, which we're going to look through eventually. So for example, the first one we're going to learn is the Turtle library, or there's the math library, or there's all the graphical libraries. So instead of having to rebuild all that, you can actually reuse those library codes, okay, which we're going to learn about. And then it's also machine dependent. The way that we code an iPhone compared to the way that we can code a computer to a PlayStation, they actually use different languages or different ways of zeros and ones to control the hardware. So it's just because you write an awesome bit of code on your Mac OS, it doesn't actually transfer to the PC equivalent straight away because of the operating system. So it can be machine dependent when we do the binary code. So we need to make sure that we don't we build it in a programming language that fixes all these problems, okay, which is why we're going to be learning Python. So there's this really cool quote: the art of programming is the art of organizing complexity, okay? And that is what our job as a computer scientist is. And then there's a really funny little joke, right? So real programmers code in binary, just using 0, 1, and enter. I personally don't agree with that, but that's a joke. So first of all, what is a programming language? You've probably heard of all these different things like Python, Java, C, C#, JavaScript, C++, Pascal, COBOL, Delphi, assembly. There's a whole heap of different programming languages out there. There's heaps, right? There's hundreds and hundreds of them. There are a few that are more popular though, and that's why we're we're going to be looking at. Okay, so programming language is a set of conventions for communicating an algorithm. Okay, the purpose is specifying an algorithm and its data, communicating to other people, and then establishing the correctness of what was been written. Okay, so I'm going to show you a quick little video here that shows the most popular programming languages on Stack Overflow. Goes from 2012 up to I think it's 2018. And what you'll see is C# is the most popular in 2009. Okay, C# is a programming language by Microsoft. Then Java became a little bit more popular. And then PHP, JavaScript, but you'll see Python's right down here and still within the top 1, 2, 3, 4, 5. And then you'll see C, which was one of the older languages, still existing. And then slowly Java creeps up and overtakes it. C# still is there. So C# is used for things like Unity, so for the game development that we'll eventually do. So it's still relevant. And then what you should see, I think it's around 2016, suddenly Python becomes super popular. And that's basically because it was awesome for data science. So for people trying to predict what's going to happen inside of stock market, or trying to predict the weather, all those different things. Python is super awesome as a data scientist. Not to say JavaScript isn't either, but Python is quite good for that. JavaScript's probably better for more of your website development, so the games that you see online and all that different type of things. But I found that was really cool because towards the end, there's more questions being asked on this website of Python than everything else. So how do we get a computer to understand? Okay, so a computer will take a high level language, take it through a thing called a compiler, and then abracadabra, it will change it into the binary zeros and ones that it will work. So our job as a computer scientist is to understand how these high level programming languages work, like C, Python, and all that. And then we take it through either a compiler or a translator, and then it spits out that low level zeros and ones. Okay, you probably know Bruce Lee before. There is no 100% right way of using a programming language. Okay, so all programming languages have their advantages and their disadvantages. So I liken this to learning a martial art. Okay, and here's the quote that I love. So absorb what is useful, discard what is not, and then add what is uniquely your own. So you're right, the whole goal behind this is to put in what is useful for you when you're learning how to code, and make sure you absorb that in. Okay, so there's going to be different ways that I do it that might not necessarily be the same way that you do it. Okay, it's up to you to work out how that's going to work. There's a whole set of reasons why Python's great, and we're actually going to go through and see the reasons why I've chosen this. Okay, so Python is super powerful and fast. You can type code super easily, and it's got some real depth and grunt behind it. It plays well with others, so it's integratable with other programming languages pretty reasonably well. It runs everywhere, so because it's such a lightweight framework, it actually runs on other systems quite well. It's friendly and easy to learn, which hopefully after we look at some of the other examples of other languages, you'll go, oh, I see why we went this way. And then it's open source, so it's free to everyone to sort of play around with, and all the libraries are open as well. So there's no sort of mysterious, what's this library from? It actually is all just open and transparent from the very beginning. Okay, so what is Python's? Okay, so Python is a programming language that is both very simple and easy to learn for a beginner program. Okay, it's also scalable to some really large world projects. For this course, we'll be using Python version 3, and the systems that use Python, here's some examples: some warehouse robotics, Google Spider and search engine, Battlefield 2 for the older games, and NASA. So these are just some of the examples that Python uses Python. So how do we actually install Python? Super easy. On a Mac, you actually have it preloaded. But if we want to get the latest version, basically we click on this link here. Up will come up this, or you can go python.org/downloads. You click on download Python, and then you will have it installed. Okay. That's the same goes for our Mac friends as well. So when we translate something, we've got this question that we need to address from the very beginning. What's the difference between an interpreter versus a compiler? Okay, so think about what interpreting means versus compiling means. Okay, so when we're translating, we can do either of those options. We can interpret something or we can compile it. So imagine when we interpret, it's like a conversation. So you've probably seen an interpreter like, I know United Nations when someone's speaking. So for example, if I was speaking to someone that's from Germany, they might not necessarily understand English. So we would have an intermediate or someone in between that interprets it for us. And it's like a conversation. So I don't know, if I said in Japanese, Watashi no Hendo sensei onegaishimasu, the translator would then take that information and then give it to the other person saying, his name is Mr. Henderson and he's pleased to meet you. All right. Interpreting is really good at doing one statement at a time. So I'll tell the interpreter something, then it translates it. And it's good for simple programs. Okay. The different version of it then is a compiler. So compiling is like making a book. So instead of going one statement at a time and then converting it, it gets all of the statements that we've written in our programming language and converts it all in one go. And this is better for more complex programs. So interpreter is great if we want to do fast, simple programs, whereas a compiler is better if we want to do more complex. So my question to you then is, what does Python run on? Does it run on an interpreter or a compiler? Okay. And the answer to that, it actually runs on an interpreter. Okay. So it runs the code line by line. However, we can write scripts that gets fed into the interpreter, but it still only be executed in that line by line. Okay. So you wouldn't use Python necessarily to build something complex like Fortnite or a big game or an application or Microsoft Word or Photoshop or anything like that. You would use another language like C++ or C# or Java even. Whereas if we're building something that's simple and just getting our head around how to code, Python is amazing for that, which is why, but it uses an interpreter instead of a compiler. Okay. So it runs the line code by code, the code line by line. However, we can write a script that we can feed into this interpreter. And then this is what IDLE is. So IDLE is the thing that you just downloaded before, and it stands for the Integrated Development Environment. Okay. It's what we use to run and test Python code. Okay. So for the beginning of this course, this is what we're going to do. So if you open up IDLE, this is what it would look like. And I'll actually open up on my computer. Sorry, I'm using the older version, but this is what it would look like. And what you see here is basically the interpreter. So I can put queries into this, right? So I'm going to do 2 + 2 and then press enter and it will spit out the answers for me. So no matter how complex math, right? We might make this a little bit harder. So we'll go 450, take away 19999, and it does it automatically for us, which is pretty cool. Okay. So the first thing that we always do when we learn a programming language is we learn how to do the ancient tradition of Hello World. Okay. So basically, whenever we get to a new language, we use Hello World as a starting point so that we can understand how the programming language works, really basically with its normal structure. Okay. So to start with Hello World in Python, it's actually super easy. This is all you have to do. Okay. You literally type this code in. So you'll go print, open parentheses, and then a quotation mark to represent that there's going to be some text. So then hello, comma, world with capital H and W, exclamation mark, quotation mark, and then the parentheses on the end. So if we open up IDLE again, I'm going to go print hello. Sorry, let's slow it down. So print open bracket, quotation mark, HELLO, comma, world, exclamation mark, quotation there. And then if I press enter, bam, it's done it. It said hello world. Okay. Now that might seem quite trivial, but it's actually quite awesome how simple Python does this. So it does it all in one line and it's super easy. You can just jump in and do it. Okay. And then this is what the output would look like. So how hello world looks like in other languages, just so that you can see it. Now, I'm not expecting you to understand these languages. Just appreciate how simple our Python one-liner was. So if we were to write it in C, this is the way it would need to be written. So you need to include, and then you would go int main void puts hello world. Then C++, similar to C, but it would use the standard output. So std semicolon semicolon C out, arrow arrow hello world, and then return 0 because it needs to return a value. C# would then use the system, make a class called program, then make a mainline function, and then do console.writeLine. Delphi would do it like this, so write line hello world. Java does it even harder, so if we want to make an actual interaction way of doing it, this is the way it could work. Visual Basic.net looks like that, and Pascal looks like that. So the point of this is our happy one-liner is quite easy as a programming language to pick up and use. Okay, so you can start coding super simple. So to begin with, what I'm going to get you to do is I've found this awesome website called Coding Combat. Okay, so Code Combat, basically we'll use that link there. So you just click on that, or alternatively you can use the class code lazy north sad, and then use your school email address to create an account, and then basically log in and go from there. Now I'm going to create videos to show you, I think there was 20 different activities that they have with this introductory course. Highly recommend it. If you do this, it will put you in good stead for all the rest of the content that we're going to cover. So they have a really good introductory program. I would also recommend possibly buying a subscription. I think it's $9 a month or something like that. It's amazing. They have one of the best programs that are available online for learning the basics of Python super quickly. So just use your student email and then create an account. So this is what it will look like when you jump in. So you'll have the little character down here. You have the instructions that you need to do. You then have all the different methods or functions that you can do, and then you just type them. So if we want to go right, down, then right, you literally just go hero.move right, and then enter because it's in a sequence. Then you go hero.move down, and then hero.move right. Okay, but they have a whole heap of hints here. It's super effective, and yeah, basically that should help. Awesome. So hopefully you've learned something today about why binary code works and why we use a programming language such as Python instead of writing just in zeros and ones. Thank you very much, and see you next time with Steamer Steve. See ya.